we're going to jump right in. I'm going to assume that you folks know a bit about this topic, but perhaps we can begin with Matt Roberts from Amdocs to begin setting the table for us. So we know big data is a major disruption in the world of business intelligence. The companies have access to all kinds of information about individual, its customers and its employees. I was wondering if we could start by talking about how companies are using real-time data today in ways that maybe wouldn't have been possible even a year ago. Let's just start with a general question.
Okay, yeah. Can everybody hear me? I'm talking into this, yeah? Okay, there we go. So it's a really interesting area, and we've seen a lot of changes over the last couple of years in the service providers that we work with across the world. And there's obviously this drive to data empowerment and becoming a data-driven business. Now, we did a survey recently with IDC that is available on our webpage, where we came out with some really fascinating insights across the world from telcos. And one of their big priorities is a drive towards real-time data. And I'll just give you a use case, an example of where you can use that real-time data to improve the customer experience, for example. So at Amdocs, of course, we generate some of the most valuable BSS or business data for our customers. But we made an acquisition, or a couple of acquisitions a few years ago, where we could bring in network and RAN data. So here's the scenario. You're in London, you're on Regent Street, for example, and you're having, Regent Street. Dawn probably does if she likes shopping. But
I hate it actually, but I don't.
Well, if you have a problem with your coverage, you would call your service provider, and your service provider's first line support would typically say, okay, where are you? And you'd say Regent Street, and they'd say at the top of Regent Street, at the bottom of Regent Street, and you'd go through this whole process to try and identify your location. And then they would go back to their second line support to find out what network issues were going on. So that would be a fairly laborious customer experience. But what we can do is provide that location and network data in real time to the customer service agent. So you then call in and say, okay, I'm having coverage in London, and they can say, okay, Mr. Roberts, I can see exactly where you are. I know precisely what issues are going on, and then deal with that call in a much more expedient and appealing fashion. So I think that's one example of where it's very beneficial.
I mean, before we move on, are there other examples? We're well represented here with people who put together the infrastructure that enables a lot of this real-time communication. Are there other illustrations of how corporations are currently using real-time data and location data to enhance services or to deploy workers more efficiently? I'll just throw it open.
Sure. Well, can you hear me?
Yep.
I think if you look across all of the OSS providers and the suite of OSS solutions that are out there, everything from network troubleshooting and issue detection all the way up really into the CEM stack, the leveraging of data for real-time troubleshooting, quality of service monitoring has come light years in the last 4 or 5 years, and now the ability to do a lot of the things that Matt is talking about are becoming table stakes for most of the providers out there. And it's all a function of being able to leverage the utility value of that underlying data across a suite of applications that needs to digest and act on it in relatively real time.
I wanted to talk about sort of this hot topic of contextual customer engagement apps. So analyzing the signals that my mobile devices are sending out in real time to kind of predict consumer behavior. I was wondering if Matt and others could talk about this emerging area of contextual customer engagement apps. So how we're using real-time data and analytics to sort of predict behavior and market to consumers. Anyone?
Well, it's if you think about the amount of data that's coming off of the networks every day, it's astonishing. It's important to understand what you need to capture real time and what you might not need to capture real time, because it's a it's computational heavy lifting to do a lot of this work. A billion records, just to give you an idea. If you dealt with one record every second, it would take over 31 years to deal with a billion records. So imagine how much data has got to get processed and analyzed in a relatively short period of time. And each of you are carrying around a device, as well as billions of other people around the world, that are constantly attaching to the networks, to different networks, switching to Wi-Fi, switching back to LTE, dropping off LTE to 3G. These are all events that are important to capture in order to understand the type of experience that the customer, that the device is having on the networks.
All right. I wanted to talk about how, Tom, I'd like to involve you in the conversation, how the use of location data is evolving. There was a time, I mean, we're all here in this room accustomed to receiving promotions. Say when we walk past a store, or drive past a store, we'll receive a notification on our phone to try to lure us through the front door. But increasingly, app providers and mobile carriers have more than just 2 points of data, where I live and where I'm currently located. So how has this space evolved? And what are some of the applications we're beginning to see?
Yeah, great. So I'm Tom from Verve Mobile.
Tom, do you want to move your microphone closer?
How's that? Can you guys hear me? We started Verve in 2005, completely solely focused on location marketing, right? With the idea that mobile should be the best medium of all time for connecting with and engaging consumers because of location. Real-time location is really what makes it unique. And before that, I was at Nokia for about 10 years, where we were talking about this stuff back in 96, 97, 98. So it's really an area that has evolved for 20 years, right? And so in 2010, the big question was the year of mobile. You know, officially, from my point of view, 2010 was the year of mobile. We as a company started selling to merchants and advertisers and retailers this ability to connect with consumers in the marketplace using GPS off the phone, which are best. But back then we would use zip codes, we use location of the publisher, GPS when we could get it, cellular tower, all kinds of stuff, right? And today, the networks have evolved so much that the best media that we can get has real-time lat longs that we pull directly from the device. In an environment where the consumer says, yes, you can use my location because you're going to send me something better, right? There's a value exchange, right? So for us, it's been very exciting. The market's grown like crazy. Here in the US, we're one of the, this is kind of the leading market globally for this kind of stuff. We're one of the players. There's like 20 players that are out here doing this stuff. And we're getting to the point where it used to be 2 years ago, to your example, you'd walk past the store, it would be geofenced by 5 miles, and you would get pounded by ads to come into our store.
Yeah, exactly what I wanted, is spam on a new platform,
Compared to online advertising, it was 500% better though, right? Like, so it actually, the fact that you tied it to a couple miles versus blasting a whole DMA, it was better for everyone. It was better for the consumer. And language using locations like you're a mile away is very, very effective. So consumers have said yes, right? Like, we have a very high opt-in rate with all our publishers, and we're in about 5,000 apps. We've worked with about 25,000 apps. And so today, the gold standard is still real-time GPS off the device, for that moment. But most recently, we've acquired a few companies in the beacon space, and so that's kind of the next step, and that's where, which is all IoT oriented, Bluetooth, devices, a device right here, which is the stage, is meaningful, it has significant context, and when you get into this environment, the wireless, the satellite chips are worthless pretty much, and the wireless starts breaking down. So the business is evolving that way to get closer and closer to deliver messages that you want, that you love, but then proving it, right? And that's the big key, attribution on the back end, and that's what a lot of IoT data is about. It's about attribution, proving that all this effort is actually succeeding.
Well, let's layer on another bit of sophistication. I mean, this is a nice introduction to the role of artificial intelligence. So you have a tremendous amount of information about me, my current location, where I've gone historically. Waze has learned a tremendous amount about me and where I logically commute, and gives me information that I find valuable, like when I should leave my home to get to my destination on time. In LA, that's always a complexity. So what is the role of artificial intelligence or machine learning, and how is that going to change the mobile experience? Anybody? You make eye contact, that means you own it. Go down.
Personally, I think it's, when we look at artificial intelligence and machine learning, I think where it's really interesting is we follow the Gartner hype cycle. So
Yes.
every year, Gartner has the technology that is at the top of the hype. And 2 years ago, it was big data, and big data was tracking its way to the top of that hype cycle. Then last year, it was replaced by IoT. Mm-hmm. And I head up marketing for big data, so I was really annoyed about that. But then this year, machine learning is at the top of the hype cycle. I can't open an edition of The Economist every week without there being an article in there about machine learning and artificial intelligence. So where is it going? What is it going to do? I think one of the most interesting examples I've seen of this was just announced last week through IBM, actually, and that was IBM Watson.
Right.
Being able to watch a movie, pull out the most impactful scenes, and then build the most compelling trailer based on, and it can do that by itself through artificial
They're marketing
intelligence.
people in LA blanching even as you speak. All right, so.
I know, I think it's incredible. So I think in the world of telco, we're starting to move into the machine learning environment now, but I think it's so exciting and it opens up so many interesting use cases.
But what does it mean for like network? So what does this intelligence mean for network operators? I assume that people in this room are not, like me, the great unwashed, but we have some sophistication. So what are the implications for managing copious volumes of data? We'll get to IoT in a moment because that will only increase the flow of information exponentially. So what are the potential implications of adding intelligence to the data in terms of predictive analytics?
Well, it's huge, and I would argue that most of the elements in the last discussion are all very closely linked. So if you talk about big data, if you talk about machine learning, if you talk about IoT, and if you talk about the instrumentation of the telecommunications infrastructure, they're all fairly inextricably linked when you start to look at something like IoT. And dealing with that level of information has huge benefits, but also huge challenges associated with it. And one of the issues generally comes down to the architectural deployment options and how to really leverage the underlying data. There's
So
millions.
be concrete for me. It's a little abstract.
Pardon me?
Be a little bit more concrete. What are we talking about?
Okay, so let's say and not to go too deep into like databases and stuff, but let's say the world is moving to virtualized applications, cloud-based deployments, and generally speaking, the prevailing architecture is a data lake architecture, and it has a lot of benefits. So people will stand up Hadoop or Spark or MongoDB, depending upon the nature of the use case, and that generally is designed to scale really well, and that's a good thing. So if somebody calls up and they need service on a particular phone, for example, something like that technology is very good at zeroing in on that phone and pulling information about it. But if you're trying to do correlation analysis, and I'm going to try to understand contextually what's going on across a variety of different data sources and gain that insight, that's the realm of the long-running query where I may have a 1,000-node Hadoop cluster and I take it all out of commission because I'm running one of these jobs that, to quote an IT operations manager I heard one day, the most important person in the infrastructure is becoming the person they get to unplug the machine from the wall when one of the data scientists goes crazy. Now that's a bit of an extreme, but in embracing this sort of new way of doing things, you have to take stock in how do I accomplish my goals? It's not just, hey, I've got this new technology. That would be like me saying, hey, I bought a Ferrari and it'll go 190 miles an hour, and fail to contemplate that driving down my street would not be a good place to test that out, right? So you gotta keep everything in perspective, and it presents some challenges. Conversely, though, it does certainly open up an incredible opportunity in terms of looking at operational analytics, predictive analytics, investigative analytics, and ultimately feeding machine learning. That's kind of the holy grail of not only leveraging big data, but IoT in the first place. But that all speaks to the architecture and how you establish it.
Yeah, Brian, are there sort of near-term implications that you see of the use, carriers being able to employ artificial intelligence in terms of network management?
Oh, absolutely. The carriers with the self-organizing networks
Right.
I assume that's where you're
Yes.
where you're headed with that. And understanding what's happening on the network and being able to react to it very quickly is going to help in so many different ways, and increasing the capacity of the network would be one very good example. You have, at any given time, you have channels that are dedicated to covering a specific area, and if there's a way to redirect those channels as necessary and adjust them based upon what the needs are at a given time, then that can significantly improve the efficiency of the network.
I wanted to begin to talk about the use of sort of predictive analytics in helping helping the carriers sort of provide adequate coverage. There are dense metro areas like Los Angeles again, where you have tremendous loads that need to be managed, and sort of more remote places, sort of sparsely populated like Albuquerque, where that's a different set of issues. So how are predictive analytics being employed, or how will they be employed to try to maximize coverage?
So we've tracked the coverage and the spectrum and so forth in the industry for years and years, and people used to just ask, can I go to Albuquerque? Can I go to Albuquerque and use my phone? Yes or no? Now what they want to know is, can I go to that street corner in Albuquerque? Or
Right.
can I go to this back office conference room in this,
It's true.
densely built building, and have access indoors. So the level of granularity that is desired today in the information associated with network availability and network performance has, just like everything else, just exploded.
Right.
We are so used to ourselves being able to walk near a window if we start having trouble on a call, right? And if we drop a call or it gets a little scratchy as we're driving along, we can say, wait a minute, I'm in a bad spot, I'll be out of it shortly. If you're putting a sensor in a fixed spot, if the coverage is bad today, the likelihood is going to be that the coverage is bad tomorrow,
Right.
unless you actually do something about it. And the operators are certainly limited in the amount of funding that they have, the CapEx funding that they've got for their infrastructure. And so moving forward, yes, they've got to be able to deploy that infrastructure more efficiently. They need to know where the network exists, where it's good, where it's weak, where it is, where the capacity needs. Just because you have 5 bars doesn't mean that
Right.
you've got great coverage. You may have great signal, but you don't have a great experience.
Right.
And if I can add to that,
Yeah.
I think one of the things that we have is, it's you can look at the network and say, there's weaknesses here or there's problems here, but from a service provider's perspective, they do have a finite amount of resource and CapEx that they can spend. So they really need to, they're not going to be able to improve everything, but where should they prioritize? And so what they can do is overlay that network data with the BSS data, with the customer value data, so that you're investing in the network where your VIP customers are, where people have got a high propensity to churn, where people have higher ARPU. So if you invest in those areas where the money is, you drive a better customer experience and it's more beneficial for the service provider. So for example, I'm from a place in the United Kingdom called Wales. I don't know if anybody's heard of it. But there's a lot of sheep in Wales. Now, if you were looking at the network and you'd looked at Wales, the last place you'd want to invest is a place with a field full of sheep. Right now, anyway, until IoT really kicks off. So it's really about targeting those high-value customers.
Yeah.
Go ahead.
And if I could add one more dimension to that, if you take everything you just heard in terms of the available resources and what the carrier can know about their customers, and then bake into that other data sources like there's a football game at Lambeau Field or whatever, and I happen to know that while the normal patterns of usage are X, I can predict that based on certain events, I know that the load on the network is about to increase, and therefore I know enough about what's about to happen based on predictive analytics to know that I need to tune whatever I can tune and then prepare for the backlash of what I can't accommodate. But that's seriously going on.
Yeah, I guess we'll ask the question now, even though we can have this conversation. But I mean, there's so much information that companies have access to, and we'll talk soon about IoT and how that's just going to continue to ramp. So, how are companies using sort of data sampling to make sense of it all? Because there's no way, I mean, it seems logically, that companies can synthesize all this information in real time. There has to be, some other approach. So talk to me.
Maybe yes, maybe no.
Okay.
So for starters, sampling. So when you think about sampling,
All right. So define it.
So when somebody's sampling, let's just say I have, 1 billion records, but I don't have the time or the resources to process 1 billion records. So I'm going to apply certain statistical techniques to figure out, I'm going to pull, let's say, 10 to 15% of that billion records, and I'm going to analyze that subset, and I'm going to use far less resources, and I'm going to get the answer back far quicker, but I'm going to know that that's an approximation. And the implied expectation is that an approximation is good enough for that particular use case. That's true sometimes, it's not true sometimes, but here's the thought process that I would put on the table. Sampling has a few drawbacks. Number one is, if you're sampling data, typically that only works if you're sampling from one set of data, one table of data. Because if I'm going to try to sample across multiple tables, I actually am joining that information, and by definition, I'm reducing the sample size down to something that's going to be fairly meaningless. Number two is, I have to decide if the use case allows for missing outliers. So if I'm doing network intrusion detection, that's really a bad use case for missing outliers. Network troubleshooting would be another great example. So a lot of the OSS suite can't really use sampling effectively because of some of the implications. I would argue, based on some things that I'm involved with, there is a way to do what I would call the creation of statistical models, and you'll hear more about this, I think, soon. You can basically do 100% introspection on data going into massive amounts of a data lake architecture and create statistical models that are a much more robust, complete introspection of the data, and you can query the statistical model versus querying the underlying data, and that can accommodate joins. That can, these models can be written where this is where machine learning comes in. As they're looking at the data that's coming in, you can actually predict where a record should lie, and if it falls outside of a certain tolerance, you can start to write outlier files. So if I'm doing something like network intrusion detection, I actually go right to the outlier file. And if I'm doing something like behavioral modeling, which is another great example of where I'm going to use approximation, I want to paint the curve of the behavioral model by eliminating and pulling out the outliers so I get a truer model of what I'm really expecting. But here's the net on all of this. Sampling is not a bad technology, but it's indicative of the load coming on the system, whether it's a carrier or anything relative to IoT. The amount of data is crushing, and it requires an accommodation in order to gain equivalent insight in a way that's technologically practical, not just possible.
Any other thoughts before I move on?
I'll talk about the management of the data, right? Which is
right.
The big data and machine learning. So and continuing the discussion of how location data is evolving. In 2007, We used to brag to our board that we're one of the largest mobile content platforms in the U.S. and we had 100 million ad impressions a month, and we reached 10 million people. And that was enough to keep the company going. So we kept growing, so we kept getting funding. Today, we see 200 million devices in the US, 200 million unique users, and we manage 500 billion ad impressions a month. And within an ad impression, there's probably like 10 attributes that we're tracking. So it's truly trillions of data points. And ultimately, we're trying to tie all that data back to the 200 million devices so that, using the Starbucks example again, when you walk by Starbucks, you get the ad based on loyalty, based on previous experience, based on how many times you've gone to Starbucks. That is going to actually drive you in to buy a Starbucks, right?
Dawn,
like,
you want your soy latte now.
Exactly.
Right?
And here's $1 off. Here's a treat receipt, right? Like, so perfect advertising. And the thing that people don't talk about big data is that it's a pain in the ass. Actually, it's actually quite expensive. And so it's great because we have this vision of being able to utilize all these data points and attributes to drive the perfect advertising message. But ultimately, I look at my Amazon bill and I'm just like, oh my God, like this is not going to work, right? This doesn't scale. And Amazon's all about scaling, right? So it's for a company like us, we're a small company, we have about 200 employees. So we have to manage that, and then writing off of Don's sampling becomes an important part. Taking statistically relevant sets to test. So we're ultimately trying to test targeting methodologies, and so that's the only way we could do it, right? Is to take like a 2%, 3% base and see, does that result in a positive experience? And if it does, then we do more and more, right?
So I'm going to pile more data on to you. Gartner, the research firm, estimates that over the next 4 years, there will be 21 billion internet-connected devices. So the Internet of Things is going to just amplify the amount of data traversing the network exponentially, everything from traffic monitoring in the cities to seismic monitoring somewhere in California. So how will the networks cope with this glut of data and demand on the network?
Well, a lot of this, a lot of the data that's going to be coming from sensors is going to be very small transactions taking place over the network.
Right.
So it's not as if they're going to put the type of load individually that we do downloading a video from YouTube or watching our Netflix on our tablet. So the network's going to be able to handle a great many of these sensors because they're going to be very, very specialized to look for specific things. And when you have millions or billions of these devices, then the amount of data that you're transferring becomes very precious.
Right.
And you're going to be very careful about how much, based upon what your specific business case is or what your use case is. Mm-hmm. If I could tie in one more thing.
Sure.
Something that was mentioned, because the retailers have gotten so interested in what's going forward, and obviously we're seeing successful businesses being built from that. That network availability issue and the limited CapEx that the operators have is going to drive the enterprises who are now benefiting from the existence of wireless coverage to be more involved in taking part in extending it and providing more depth inside of the venues that they control.
Ah, that's interesting. Okay. Well, I'm hoping we can talk a bit about how businesses can make sense of the additional data that's provided. One of you, in our previous conversation, we were talking a bit about this topic, and one of you used the example of a McDonald's. At some point in the future, all of the cooking equipment will be connected to the internet, and if I'm a local franchise operator, I might want to have all that information centralized and maybe merge it with, staffing, so that I can, or even glean information from beacons to know when I'm likely to have peak demand times. There's a baseball game going on, I might have a surge afterwards. What tools exist, and how can businesses begin to glean and manage the information that's going to be thrown off by IoT?
Right.
Go for it.
So, if you think about it, right now, most of the IoT-enabled subsystems are basically closed loop message response systems where the data coming off the sensors on the low, let's use McDonald's as the example then. The low volume fryer goes to GE, and the HVAC system goes to Honeywell, and the lighting system goes to Lutron. And that's all good because you're running the McDonald's and now it's much more efficient than it used to be because you can control it from your iPhone and your fryer tells you when it's going to break. But at some point, the person running McDonald's says, hey, I think if I could look at my kitchen equipment and my HVAC and my entertainment system and my lighting system and my beacon system and merge that with my point of sale and my crew scheduling and my inventory, and also merge it with external data, whether it's demographic data or IoT data coming in from the city, like pedestrian traffic or street traffic, I can start to do predictive analytics, I can get a much more granular signature and I can optimize against that. The issue around the data is really that if the product providers own that data and they control how McDonald's sees it, then they lose that ability to leverage the data. So the trick is going to be, and I think that we'll see this migration in the industry, where it'll move to more of what I would characterize as a first receiver model, where McDonald's or the enterprise that owns the IoT subsystems would be the control point for the data, but then they would logically want to have agreements with the subsystem providers so that Lutron and Honeywell and Bosch and everybody else still get the data they were already getting, still control the firmware on those systems. But the whole goal is for everybody to leverage the utility value of the data, whether it's the local McDonald's, McDonald's region, Bosch, or even the FDA or third-party supply chain partners. Mm-hmm. But it comes down to an architectural approach of how do I establish how the IoT data is collected, stored, and then propagated to the appropriate place at the appropriate time.
This question, go ahead.
No, and to add to that, I think it's also a cultural change as well. Right. Because I think if we just look at telecommunications, it's only now that within an organization they're prepared to share data between departments. Right. That's what we're seeing. Right. So the network guys would never talk to marketing. Marketing would very rarely talk to care. And I've really only seen it in the last 18 months that these cross-company initiatives to cross-pollinate the data within an organization. So as a marketeer, Vodafone Group would typically spend millions of pounds looking for information on its customers from outside the business, when actually it had it at its fingertips. But when we look at IoT, that cross-pollination of data between industries and different vendors, I mean, that's going to require a lot of work and a lot of cultural change. But an interesting example of where industries have shared data to the benefit of consumers was about 12 months ago. There was O2 in the UK, a big service provider owned by Telefonica Group, that did a deal with NBNA, the credit card company, where they were sharing, going back to our original point on location data on their customer base with the credit card company. So if the customer, say, I try to make a credit card transaction in London right now, but the network is saying I'm in Las Vegas, then immediately that transaction is declined. So you can really go after simple use cases around fraud prevention and by that cross-pollination of data between different companies and different industries.
Mm-hmm. Go ahead, Tom.
I just wanted to add to that. So I had breakfast this morning with a company called Wireless Registry, which is tracking all the signals, IoT signals ultimately. So it'll be a place to go to identify and help.
I can't hear you, Tom. I'm sorry.
Kind of like tracking all the IoT signals. You mentioned 22 billion devices in a couple of years, and it's already happening today. So their data shows, this is a company called Wireless Registry in DC. Their data shows that a device walks past or connects or sees 15,000 signals a day. Everything from Fitbits, your Apple Watch, to Wi-Fi, to Bluetooth. Like, that is just an incredible number already. That's happening today, and that's not the 22 billion coming down the road, right? Like, so it's already a huge data opportunity, but also a data headache, right? That we're all trying to manage through. That's why I think the name of these panels is 5G use cases, right? Like 5G is going to be extremely important for the continued evolution of all this stuff, ultimately.
I'm going to open the floor in about 6 minutes to you folks, so begin thinking about your questions. You introduced the topic of 5G, so let's
Real
go
quick
there.
on the IoT. So Don mentioned a point about the business models, and so we're deep into this right now with grocers, with CPG product producers, with theaters, and they're all rolling out beacons, they're all rolling out these little devices, and beacons are getting smaller and smaller so that they're almost invisible, and they'll last a year. And there's a no one knows who owns the data. And everyone claims that they own the data,
right.
but it's getting to a point where these sensors are so small that people are just going to start putting them in everywhere, and then there won't be a data conversation. There'll be just data flowing everywhere, right? Because a Kroger, ultimately can't control. I was talking to one grocer, said, I'm just going to put them in the box. I'm tired of them telling me what I can and can't do. I already pay a lot of money in shopper marketing, so for them to say I can't track what's happening is not, and they can do it. So Kroger's not going to research every box to identify what's in it or not. So that's a big issue, the business models.
Yeah. I wanted to tell you, implied in your answer is this larger question of privacy. So we're talking about all this data about us being aggregated and analyzed. Matt, we were talking about sort of the UK as this surveillance nation. There's a study that came out in 2013 that found that there were nearly 6 million cameras observing the population, and only 70,000 of them are actually operated by police or some government entity. So what are the privacy implications here, and what are the reasonable expectations of privacy at this time when there's so much that's knowable about us?
Well, yeah, first of all, I was really surprised about that statistic about the UK. I was like, oh my God. I'll go home, I'll be looking everywhere now. Like, oh my God, what's going on? But yeah, whenever you get into a discussion about data, the privacy will always come up, right? And I think, from our perspective, everything has to be opt-in, everything has to be anonymized. And I think there has to be a certain degree of responsibility as well. And I think we've moved away now, and there were negative connotations with big data when it was originally being defined. And a lot of people just thought it was simply selling customer data to third parties for them to...
I leave that to my bank to do.
Yeah. And it's, and it's understandable why people would be concerned about that. I think from our perspective, it's about service providers being responsible, anonymizing and opting, allowing consumers to opt in when their data is being used. We actually did a study a couple of years ago, and we asked consumers if we could use your data anonymized and with your permission to give you a better customer experience and to drive down the cost of your service, would you be okay with that? And resoundingly they said, yeah, we're fine with that. Mm-hmm. So it is that responsibility element, and that needs to be considered as well.
But I think to a large degree this is a generational thing as well. The expectation of privacy, if you're 40, 50, 60 years old, is very different than it is for the 20-year-olds today. They are playing games online with people they never knew. They've never met in person, and they expect that what's taking place on their handsets is going to some degree be tracked. So in some respects, privacy is, the definition of privacy, I think, is even changing.
Mm-hmm. Well, it's really an interesting observation. In an era of Facebook and social media, it seems that there is no privacy, but we're beginning to see some pushback. The advent of Snapchat, and an anonymized, ephemeral app seems to be a response to that. So it seems like there is some sort of sensitivity, and the data is global in nature, so it would seem that there might be differences in how, say, for example, the EU might treat privacy versus the US versus other parts of the world. So is there any forum where this is being aired, and what is there some sort of consensus around data privacy, or is it just, does it vary by region and by provider?
Well, to give you an
Well,
example
in the,
of, sorry.
in mobile marketing, I mean, as long as we've been talking about location and acquiring location, there's been associations to help guide the discussion of privacy policy, right? And so in MMA, Mobile Marketing Association, that's one of the key offerings that they provide the industry, and they meet very closely with the FCC and the FTC, and it's a constant dialogue, right?
Right.
Like, and it's constantly evolving too.
Right.
So if you look at like Apple's iOS 10 coming out, where the permissions are going to be more forward, they're going to be more obvious, they're going to be easier to access, and that's been happening throughout Apple's, the iPhone's evolution, is that it's gotten more transparent and clear. So my son, who's 10, knows he can go in and turn location off, right? So that education and that control, it's about consumer control ultimately. The consumer decides what they want to do or use, right? That's why Uber is really good, and that's why people leave location on all the time, because they don't want to go in and out all the time. Whereas in Germany, and you talk about cultural differences, 2% leave location on, and they literally, it's very low, and versus like 80% here, and they literally will like get an Uber ride, they'll turn location on, Uber comes, they get out of the car and they turn it off, right? So it's absolutely different, obviously, market to market. We're in we have a very high opt-in rate, about 50 million users that have like an 85% opt-in rate to using location all the time, because there's a value exchange. They get local information. They feel good about it, right? So,
Right.
But we are constantly following whatever kind of Google and Apple kind of like decide what's best for consumer, which is really good. They care about the consumer, especially Apple. The industry kind of follows suit.
Okay. All right. So I've stood up here and asked a bunch of questions that I'm curious about. I want to throw it open to you folks. There must be at least one person here who has something to ask of these gentlemen.
So who has a question? We have a panel of industry leaders here waiting to answer your questions. Let's utilize this time.
Don, you mentioned briefly about anomaly detection, and I just want to learn about how we can work or integrate predictive analytics and anomaly detection. How do they work together? What's the best way to do it?
How does predictive analytics and anomaly detection work? Again, I would I would yield to the mathematicians in my company that write the algorithms, but we detect anomalous data by looking at patterns in the data as we're scanning the data itself, and we have certain boundaries where we're expecting the record to fall, and if it's out of that, we write it to an outlier file, and then over time, as you develop a history of the data, then we actually apply different algorithms in terms of trying to look for, this is sort of the realm of the data scientist looking for the signature. Let's say I'm running a network and I want to figure out what handsets and operating system combinations are most likely to fail under certain weather conditions, and then zero in on those towers and understand. So it's really harvesting massive amounts of data that may or may not be obviously correlated, and being able to get at that anomalous data in a way that's practical. Right now, technologically, all of this is possible if you have unlimited time and unlimited resources. The trick is being able to do the things we're talking about for a reasonable time and a reasonable cost. And I would argue advanced use of statistical models as an abstraction layer over massive amounts of data is probably the bridge to get to that type of capability.
Over here. Just one moment, the microphone's coming to you.
Just interested to your opinion about how predictable it is using your big data analysis on the stock market.
Yeah, we'd like some insights right now.
If I had a good answer to that, I would not be sitting here, I'm pretty sure. I mean, you know, I have some friends that run funds, and they pay a lot of money to very, very super talented, mostly mathematicians, but quants and data scientists, to try to do just that, and that's their lifeblood. I wouldn't begin to wander into that space. One of my older sons actually works for a firm that does that. He's way smarter than I am. Somebody, you guys might have a better answer.
On the location front, hedge funds are buying tons of real-time location data.
What?
Regularly, and identify. They can tell that sports authority is going under, right? Like, so they're getting ahead of these obvious trends that we all kind of know inherently. But from a stock market perspective, if you actually know that it's falling apart quickly, there's a time advantage, right? And so location data has become a very valuable tool in the kind of financial analysis.
Complete the thought for me. Does that mean that hedge funds could tell that foot traffic to Sports Authority was declining over time, and that's how?
Absolutely.
Well, you've been able to. People have been doing that for a long time. They didn't have to wait for big data to come along. They've been using satellite photography, very fresh satellite photography, to count the number of cars in the parking lots. So you often will know, if you have access to that data, what the results are going to be for a particular retailer that's got a lot of locations.
Fascinating. All right. Are there other questions? All right.
We have time for one more question.
Okay, so I have one last one. So we're looking, I'm going to throw the 5G question at you in some more framed form. This 5G has been really one of the major top themes of this conference. What is on the horizon for big data as 5G rolls out? What are just look into the future, near-term future, and tell me how this world changes with the advent of more capable wireless networks.
So from our business model perspective, 5G, I'm excited because the US is actually leading the charge with 5G, right? So both Verizon and AT&T have been very, very bullish and very aggressive on their announcements about when they're going to start rolling
Japan and China might quibble with you, but go for it.
They're not announcing like AT&T and Verizon is. So they're talking about 2017 with early networks. And the opportunity is a gigabyte connection, right? Which is crazy. Like 4G is awesome, right? 4G doing 40 megs to the phone. We used to talk about kilobits. Like so it's just more and more data, which is exciting. But then, as I mentioned earlier, it's also like, oh my God, how do I manage more and more data? That's where AI and machine learning really need to start kicking into high gear, right? Because that's the only way you'll be able to take advantage of the opportunity. There's going to be a hell of a lot more video, right? A lot more TV over the wireless networks. So and then my understanding is that 5G, the battery drain will be 10%, it'll be 90% less, right? So you're going to get more bandwidth, less battery drain. So these devices, which are already amazingly powerful, are ultimately going to take over like our whole media consumption experience.
Any final thoughts?
So the one thing I would add to that is there's a book out called The Second Machine Age, and it talks about not so much the advent of any one particular technology, but the combination of technologies and how it massively increases the pace in which we advance as a result of these combinations. And it cites things like Waze and other apps and the Google car and the technology that goes into it. And I think that 5G is an important element, but the thing to watch isn't so much 5G in and of itself, it's the other technologies, like video, as we're talking about, the other technologies that can be combined, and the yet ultra aggressive steps forward that are only available through these combination of technologies, 5G being a key one.
Last word?
Autonomous vehicles, you and I were talking about a little earlier today, and the pavilion's right here next to us. When you start marrying these various technologies together, then they're going to have impacts that are going to be very difficult to understand or define or guess to what it's going to do to society at large. If you've got a 40-minute commute every day, and you no longer have to drive your car. Right now you're not even supposed to text and drive.
Right.
Well, imagine if you can catch up on The Tonight Show, when the episode from last night as you go into work every day. And look at the impact that's going to have on the amount of video that can be consumed as people are moving from point A to point B and no longer having to pay attention to the road.
All right, on that note, thank you very much for your time, gentlemen.